down the track on the community of practice website, so that's always accessible for everyone. Welcome, everybody. Great to have everybody here. Just giving it another maybe 1 or 2 minutes to let a few more people join.
What do you think, Hillary, if we just turn our microphones off until those who are speaking? I'm just hearing a bit of background noise. I know there's...
Yeah, that'd be great. Yeah, of course, please do. Just going to do a quick chase up to our keynote speaker, or sorry, I was in a conference for the last 2 days. I'm keynote speaker in my mind. Our guest speaker today. Let's check that. Just giving it a few more minutes for those who are joining. Welcome. Okay. Excellent. So it's about 2 minutes after. What do we have? It's like we've got quite a few people on board already, a few more to come, I'm sure. But I might kick off just to keep us cruising along. I'm Hillary Cherry, and welcome everybody. And my co-conspirator, Jane Kelly, is on board here, trying to keep our weed remote sensing community practice going. So thank you all for continuing to turn up and join and listen in on some really interesting information. Every meeting we've had so far I've always learned something new. So it's pretty exciting to I'm sure I will in this next presentation as well. So I'd also like to acknowledge the traditional owners of country of the land that we're all joining from today across, it looks like at least Australia and New Zealand, and acknowledge their continuing connection to land, water, and community, and pay respects to the people, the cultures, and the elders, past and present. It's great to see so many people joining today, and we as I said before, we do record this meeting, so and we will make that recording available to all the members of the community practice. We will put the agenda in the chat, shall we, Jane? Is that okay? Actually, we do have a title for our guest speaker, David Happenbrook, today, and I will pop David's presentation title into the chat for everybody that's been waiting to hear it. And yeah, do we have to do any other bits and pieces before we kick off? Because if not, we might. It's about 5 minutes after 1, so that's given us a little bit of time to let everyone join. Have we got David on? Yes, I think we do. Hang on 1 second. Sorry, if my internet drops out, I apologize for that today. And Jane, you might have to jump on if it does. But there we've got David. Yes, I might just spotlight you, David, if that's all right. Hello. So yeah, David Happenbrook is in our team. We're fortunate enough to have David in our team here in New South Wales National Parks and Wildlife Service in our weed management team. And David is going to take us on a bit of a deep dive into the infrastructure that supports weed remote sensing. And it'd be really good because we'll get some food for thought, and we have some time after David's talk to have a bit of a discussion and think a bit more about infrastructure, the foundational stuff that supports our goals and objectives in weed remote sensing. David, shall I hand over to you? Is that all right?
Sure. Thanks, Hillary.
Thank you. Welcome.
Hey, everyone. I won't go. I appreciate that not everyone is from a super techie background. Some of you probably are. I'm sure we have people from academia here, as well as people from various government agencies and people who don't necessarily play around with code. So I won't try. I'll try not to dwell too much on super techie stuff, but I did want to use this opportunity to go through a few of the considerations that we've had to run through over the last few years regarding where we actually host some of these weed remote sensing models, because often they're very resource intensive, and that's a pretty important consideration that isn't often talked about that much. So I will share my screen. Find button. Okay, so that should be up, I think.
Yep.
Cool. So who am I? I don't think I've spoken in one of these before, so I'll do a brief intro. As Shirley said, Dave Fathenbrook. I work with Hillary in the weeds team in New South Wales National Parks. I've been with them for 2 to 3 years, somewhere in there. My background was environmental science and chemistry a bit further back. And in my studies, I worked in bush regeneration, which is where the weed connection comes in, and that's a photo of somewhere in around Parramatta, maybe. If you're good with your weeds, you'll spot trad, balloon vine, tobacco bush, my empty weed bag, lots of other garbage, and from that I somehow ended up in a software company in Canberra, which gave me a new world of software and tech to explore, and then I landed in national parks a few years back as a sort of data generalist in the weeds team. So I'm relatively new to AI and machine learning and this entire space. So this is a bit of a, I suppose, a bit of a look into my mind, the things that I think about when we're reviewing research papers of new detection models and seeing what might work for national parks, because it's a lot of what we do is sort of scanning the horizon and seeing what we might be able to apply for monitoring weeds on Park Estate. So with weed remote sensing, of course, we're trying to find particular weeds in the landscape. Often that's pretty easily delineated by if we have aerial imagery of some sort, usually drone, then we can sift through that imagery manually or get some model to do it in an automatic fashion. And it's probably a question we should ask more often and earlier in the piece, is it, depending on the scale of what we're dealing with, is it even worth going through that process of developing a model which may or may not be accurate in the end? And if it's a small area, it might be worth just getting good quality drone imagery, lots of overlap, putting together an authomosaic, and then just looking through it manually, which in many cases, particularly for threatened species, it is, because there just aren't enough instances to build a reliable training data set. And of course, with some of these priority weeds, they exist at a broad landscape scale. Best example for us is orange hawkweed. So it simply wouldn't be possible to cover that amount of area by foot, and it would definitely not be possible to review all of that imagery individually with human eyes. So this is where automation is a huge advantage. And we rely a lot on academic research to drive the sort of bleeding edge of what's out there, what's available. Most of the algorithms have roots that go back to some novel research from many years ago that then gets applied over time and is put into a productive capacity somewhere. And one of the key things that we should recognize is this published research, which is often funded through some sort of federal environmental grant. Ultimately, the objective is to apply that on the ground, and between what's published in a research paper and what will ultimately end up being someone on the ground with a spray pack or a trowel digging a weed out, there's a lot of stuff in between that has to happen. And one of the big roadblocks there is sorting out a place to actually deploy and run this stuff. And often the what I call the nitty-gritty here of setting up an environment to run these detection models isn't really discussed, and that's for good reason. It's often not really in scope. You wouldn't include all that. You wouldn't include a tutorial per se in a research paper unless that's specifically what the paper's about. But fundamentally, the uptake and application of that research relies upon people being able to deploy it somehow. So that's kind of the angle from which I'm coming at this preso. So if we think about publications, the most interesting stuff, if you're just looking at an abstract, it'll be a new technique that shows, nice precision and recall for a really nasty weed. That's interesting to all of us. The pretty interesting stuff, interesting to some, less to others, the type of sensor that's used, the model, drone characteristics, and the particular algorithm that's used, whether it's segmentation, a UNet, or common object detection algorithm as YOLO. The not very exciting stuff is, what platform did you train the model on? Where did you test it? Where did you run inference? Is it the same environment, or did you use something different? How hungry was the model? Was it expensive? Did you have to fork out lots of money for the resources that you used? And how long did it take? How long am I going to have to wait if I want to deploy this myself? And is it even, do I even have the capacity to do it? So often that stuff isn't really clear from research paper, which, as I said, is fine. It's not really in scope, but if we want to apply it, we do have to run through those considerations. So it's really about the bones behind the model is really what we need to get down to if it's going to be applied. It's not glamorous, but it's fundamental to replication of that research in an applied fashion. So there are many considerations for running detection algorithms and where that's going to go. As I said, the place where you trained a model might not be where you would be running it for inference purposes, so with fresh imagery that you've collected. And I was thinking about this before, and this is from my own work. If any of you on the call have trained models yourselves, done the codey stuff, for the last model that you worked on, how much effort would it take you to clean it up so you could put it on a public-facing repository? How long would it take to streamline all the dependencies you've installed? How long would it take to make it modular enough to install it on a completely separate system? And if you're very good, you've documented along the way, but how long would it take to document everything that you've done? And certainly for me, if I'm working on stuff, until I know that it's going to go out into the world, I'm probably going to get lazy with some of this stuff. I'll cut corners to get something to work. I mean, I don't care what any programmer says, they all do it. That takes time. So, and these are all things that have to be resolved in some fashion before this gets applied for land managers. So a few other considerations for the infrastructure that we choose. How easy is it going to be to deploy the software in a particular location? And is it intended for people with varying levels of experience? There's all sorts of tricky dependencies that you will often have to create if you're deploying this stuff in a brand new environment, which if you haven't done it before is very confusing. Performance, how much juice do we need to give this detection model? If you're familiar with that screen, that red bar, I don't know if you can see my cursor. Well, the green bar is the RAM that's allocated here, which is 16 gig, and the red bar is the swap space, which is pretend RAM, which sits on the hard drive, which it's only using because it's run out of its actual RAM and it's used up all the swap space. So in this case, it's very nearly dying, and it probably died a few seconds after that. So in that case, 24 gig of RAM was not enough. And my computer here has, which is pretty good. I think it's got 32. And I think in the end, this thing that I was running took about 60 gig of RAM, which is not very efficient. That's another issue. But the point being, if I had a model that I pulled off the internet somewhere and I tried to run it here, it wouldn't work. Resource availability. Are we going to have access to compute resources often enough? yeah, that includes disk space as well. We're often dealing with terabytes of data, which can be difficult to find a home for. We're pretty lucky in New South Wales in DQ. We have the Waratah high performance computing environment where we do have long-term archival storage. But that is something that needs to be considered. There'll be a lot of data to store. And you, of course, need a lot of computing resources to chew through it. Cost, of course, comes into it. How much you're going to have to fork out to create the conditions to run this stuff, which may be disk related, might be computing power related, and also just power, electricity, because this stuff runs all night, particularly in the middle of the season. You'll have stuff running 24/7, which consumes a lot of power. Extensibility. So if you've got one model running and you want to add another one, say it works for one particular weed, is it going to be really difficult to disentangle that? And that goes back to the word I used before, modular. Is it going to be hard to transfer those learnings to a new weed? And integration. Often we work very closely with GIS software for this sort of stuff. Of course, we're dealing with aerial imagery. It may be preferable to do this directly in GIS. That's a consideration to make as well. So yeah, in summary, there's a number of different environments, a number of different considerations when selecting an environment, and yeah, these need to be run through pretty early in the piece. So I've just summarized these into the actual infrastructure that you're using, the platform or interface that you want to use, the programming language, which is important, depends on capacity within your organization or whoever's doing it, and the particular algorithm that's being used. So different examples of infrastructure on your own machine, that's one. A centralized server, which might be a beefed up machine somewhere that you have access to, which is very convenient. It saves you flogging your own computer. And there's cloud computing. There are options that are used pretty commonly where you have access to well, in many cases, you have a pipeline available to you through Google Colab or Kaggle. It's another example where you can host data and you can use GPU resources to run through training and inference on your data, which is very nice. And there are certain amounts of credits you get for using it for free, but at a certain point, and especially if you want to use it continuously, then you will need to fork out some money for it. And other considerations for infrastructure, CUDA tools, interface with GPUs, CUDA being the NVIDIA, the sort of brains behind a lot of the interaction between the algorithms and the GPU to extract all the parallel processing power. We need to consider if that's possible in your environment. Linux and Windows, people in your organization familiar with Linux? Does that require additional training? Can you just do it in Windows, possibly? Package managers, that's another thing, to package everything up, all the dependencies, using something like Conda or SPAC, which I know of but haven't used, but that's more for people who like to build things from source. Virtualization, which is a very handy technology. Things like Windows subsystem for Linux, where, like on my machine, I have a little Linux environment running in which I can test things, which is really convenient. There's Docker, which some of you might have heard of. It's essentially like having, you have a Docker service, and then it's essentially like having little machines that run as part of that service that are entirely separate as you want it from the host system. So it's essentially like having many virtual machines. And Aptainer is another example of that that's more tailored to high performance computing environments. And of course, on an HPC, you have access to distributed processing, which will make things much quicker. The platform or interface that you use, user-friendly interfaces versus source code, the plug-and-play stuff, which we're seeing a bit more of. That's very appealing because that will open this technology to many more people. But of course, it does have limitations for more advanced users who may want to tweak models a bit more, which is perfectly understandable. Spatial data software. I know that QG, I haven't used these before, but I know that they use quite a lot. In QGIS and ArcGIS Pro, there are deep learning tools where you can complete just about this entire process within the client, which is very appealing if you're comfortable in QGIS and ArcGIS Pro, and I don't believe you have to do any coding at all, which is very nice if you're not comfortable with that. RoboFlow, which is another web-based platform. I haven't used that before, but I know that it has lots of tools that guide you through the process. I don't think you need to code in that either. And yeah, other web-based interfaces where you can interact with detection algorithms without having to build stuff yourself. WidRead is one, which I believe they just finished the more recent project, and Wildlife Insights for wildlife camera monitoring is another example, and there are plenty of other of those as well. Programming language. If you're familiar with the languages that are used for this technology, probably heard of Python. Python is far and away the most popular. I just pulled these stats from Copilot, so take them with a grain of salt, but I asked it for a summary of languages used in remote sensing detection algorithm related literature since 2020, and as expected, it's 2/3 Python, a bit of R, and MATLAB is still around. If you work in ecology much more, you're probably more familiar with R, which has lots of advantages with integration with the full world of ecological monitoring and statistical models, Bayesian modeling, that sort of stuff. And there's also a little bit of the lower level languages like C++ and Java, which if you're very, very clever and you know that stuff, then you could eke out more performance using those. Algorithm, if you're going to train your own algorithm, it of course requires a very deep review of all the available information that's out there for your given task. So one of the key things is deciding, based on the target that you're looking for, is it sufficient to have just a pair of coordinates saying where it is, or is it something that forms large patches and you actually want to segment? That's a completely different framework for computer vision. So that's something to consider. Yeah, short-term considerations, of course, that stuff we talked about before. Performance, efficiency, how hard is it to implement, where can we run the thing? Longer-term considerations, the algorithm that we're using, is it going to be obsolete soon? Is it worth pursuing if that's the case? If and when we need to upgrade it, when something better comes along, how easy will that be? Are you going to retrain the model if you have more data? Is that worth doing? And most importantly, who's going to do this? Are you going to be around to do it in years to come? Is there enough documentation to do it? These are all really important things to consider when beginning one of these projects. So lastly, I've been chatting for a while, so I'll run through these very quickly. Just a few examples to highlight different areas where we'll have different infrastructure, different interface, different programming language for specific tasks. Of course, for us, Orange Hawkweed is the easiest one to go for. 2 object detection algorithms for 2 different resolutions of drone imagery at 0.24 and it's actually 0.24 and 0.9 rather than 1 centimeter. GSD resolution. So that's an object detection algorithm. It's running on our department's high performance computing environment. There's no interface. It's all Python and Bash scripts, and it uses the YOLO V8 object detection algorithm. Another example, if I had a bit more time, I would have made these a bit nicer, so apologies. Using one of these web-hosted machine learning pipelines. So that's what I mentioned before about Google Colab and Kaggle. These can be really handy for debugging, because I certainly know for these particular programs, when you're trying to figure out where something's failing, if you leave it to run overnight, it's failed in the morning, it may be getting to the stage where after 12 hours it's been running fine and then something fails at the end. It'd be nice to know that before, so you wouldn't have to wait 12 hours to find it. Using these web-hosted environments gives you access to that GPU computing power and lets you step through in a Python notebook the execution of it, which is really handy. So in this case, the platform is Kaggle. It's a web-hosted Python notebook, written in Python, of course, and the algorithm in this case was a UNet segmentation algorithm. Another example using GIS. So in this, I just got this from the ArcGIS Pro documentation, using the ArcGIS Pro deep learning frameworks for classification tasks. So this could be running on a local environment, as in your computer, or an enterprise geodatabase. Interface is the Pro client. The language, I believe it's all through the interface, no coding required, but I presume there's some degree of Python integration, because I know that they have that in many other places. And unfortunately, I'm not sure exactly which algorithms they use. I think they use a few. But the beauty is most of that's hidden to the user if they don't want to know. Example 4, another web-hosted platform, Widremead, plug for them. That's, I believe, their infrastructure. You will access it through the web, but what they host everything on is an Amazon Web Services environment. Again, I think that's all guided. There's no coding required, and they have a few algorithms, including deep learning and non-deep learning at this point. And the last example I had here was a Bitterbush detection model that we're working with some lovely folks at Charles Darwin University to improve. This came from one of the original outputs of the work with Jane Kelly and CSU a few years ago. And this original implementation was using Google Earth Engine, which I haven't used personally, but it's also web-based, which is a bit nicer than just playing around with the raw code. And it has a Python and a JavaScript API. JavaScript is not used that much in machine learning tasks, but it's used a lot in web development. So if that's your background, then that's probably quite convenient for you. And the algorithm used here was a random forest algorithm. So after all that, that was to prime you all to consider if hopefully some of you guys are using detection models. And if you are, how you're running them. Do you run them on your own computer? Do you have a place to run them? Does someone else run them for you? Are there challenges with the approach? And if you have done some troubleshooting in this space, what have you learned not to do? And lastly, do you feel that you have enough support to maintain it in future and ideally improve it? So yeah, I'd probably open it to the floor now. Hilary, if you wanted to jump in.
Oh, that's amazing. Thanks. So it's so much to consider in there. It's almost every presentation I've seen at this Read Remote Sensing community practice has been like, Oh, there's a lot to talk about here. But yeah, thanks for the prompting questions and all the great information. I guess that's what we want to do. I guess in this community of practice is talk about it and discuss these things. So I've actually put your prompting questions in the chat.
Ah,
So if you wanted to stop sharing, we can come back together, and people are happy to join. Jump off your cameras or turn on your cameras if you like, and we can have a bit of a chat. And does anybody, I'll just stop spotlighting you, David, so we can all be on the screen. But does anybody have any thoughts or ideas or want to jump in? Or well, first off, I guess any questions specifically for David, but see any hands up? Come on, folks, don't be shy. Angus.
Yeah, hey guys. I could probably turn my camera on, but I'm working from home today, so I'm in my casual attire.
We're a casual group.
Camera. Oh, never mind. The camera's not working, so you don't get to see.
Oh well.
might have lost you there, I guess.
Might have lost. Oh, we might have been mute.
Sorry, can you hear me now?
Yeah, we got you. Yep.
Yeah, sorry. Yeah, so I'm a geospatial analyst at Sunshine Coast Council. I think we've sort of I don't know if we've actually done a presentation here yet, but we had a couple of projects through QUT. We've got an existing one at the moment, which is kind of focused on UAV remote sensing, particularly for vine species. But in our first kind of engagement with QUT, I just, first off, really awesome presentation, David, and like I was just sitting there nodding my head the whole time. But I just wanted to add in there, you mentioned something about, I guess, when the guys are doing the research, they're kind of focused on that publication side of it. As the end user, we're sort of focused on, how can we then take that research and apply it sort of operationally. So one of the data deliverables that we sort of agreed upon in those early stages was a step-by-step process that virtually anyone could follow. And I've kind of been recommending that moving forward into all these research projects, because often that is kind of the missing link. There's kind of this inferred knowledge that when you submit to a domain, that a lot of that methodology you just already know, and sometimes it's not that clear. So having a step-by-step document really helped us, and that actually went through the whole annotation, training, prediction, outcome. So yeah, I'd suggest that, if you're looking at any projects moving forward, put that on the table, because it's been really helpful for us. The other thing I just wanted to mention was you mentioned kind of the dependencies, how easy is all of this stuff to share? And one of the things we used was basically ArcGIS Pro as I guess you'd call it our backbone. ArcGIS Pro ships with its own base Python environment, and then there's the deep learning packages that actually come along with each version of ArcGIS Pro that you have. It's a really great modular way to just basically download the dependencies that you need. You don't have to go through that whole dependency resolution process using a package manager, which can be an absolute nightmare in my experience. So we used the Python environments and those deep learning dependencies that shipped with ArcPro, and then everything was developed using Python scripts. So it was kind of a mishmash of an approach, but in my eyes, I think it worked really well. So yeah, just wanted to add that. But yeah, thanks again. Great presentation.
Yeah, thanks, Angus. That's really useful. Yeah, the first point about really being explicit with the level of detail that you want out of the documentation that's provided with the research outputs is hugely important. Because yeah, most programs that I've known don't really like doing documentation. That's the boring bit. But if anyone else is going to use it, that needs to happen. And yeah, just on the using ArcGIS Pro, it sounds like, so as I mentioned before, I don't have much experience doing it in ArcGIS Pro, but was there a requirement to so you're just using the base ArcGIS Pro environment with those additional deep learning packages, or did you sort of transfer a clone to other users? Or
You can create a clone, but I'll put the link in the chat. So Pro, so Esri, I guess, provide all the installer. It's actually an installer, and they're all linked to the different versions. They've got the most recent version sitting on the front of the GitHub page, but there's actually a little drop down that says downloads for previous versions of basically Arc Pro across Windows and Linux. So it's all packaged up there, ready to go. And because they're installers, you just run the installer and it installs straight into your base environment. So you don't really need to do any cloning or anything, unless you really wanted to sort of containerize it. Yeah, it makes it super simple.
yeah, great. Thanks, Angus.
Cool. I'm nodding like I know what you're talking about. I have no clue. So glad that you guys do, though. Oh, there's Catherine. We'll let Catherine in. Welcome, Catherine. Yeah, right. Does anybody else want to chime in and tackle some of the thought-provoking questions in the chat there about what you're doing in your work? Come on, folks. Can't have a community practice without a community.
I can chime in.
Oh yeah, great. Join, please.
Well, at Landcare Australia, we recently just received a grant from CRDC in New South Wales to trial weed remead. So I like that weed remead was actually included in on this, with the intent that through the Landcare network, we'll be able to use our network and train our network into assisting landholders with accessing a platform like Weed Remead. We have drone hubs that we're setting up, hopefully continuing to set up. We are, I would say that, in this assistance. And we just did our first attempt on Weed Remead with just using color. We haven't added their machine learning into it. And I think with tying into all of this tech that we are looking at, there still needs to be a very heavy focus on timing of methodology. If you're surveying in the wrong time frame, it does not matter what our algorithms are saying or how we've written it, it still won't work. So I just wanted to highlight timing is everything in the imagery that you are trying to analyze.
Yeah, super important, particularly if it's something that's not relying on, well, no, sorry, if it is relying on a flower or something that's only there for a short amount of time, then never mind if you miss the season. So
I mean, we're currently looking at Nagurber, so it doesn't have a nice flashy flower. We've got good results on our first pass, but that is still dependent on growth stage and surrounding environment. So timing when the grasses start to go brown, but the Nagurber still is holding that vibrant color, is you still have to plan that in. So even with using the technology, we're still limited on time frames for data collection.
yeah, that's a great point. And that reminds me, I don't think she's here, Reza McVie, who works for New South Wales National Parks. She does a bit of monitoring using drones for Scotch broom, and it's not so much the timing of the broom flowering, it's the timing of the lookalike species that she has to avoid. And the Bossia and Acacias come out, then yeah, it's there's just too many false positives. So yeah, very important point.
Yeah, cool. Awesome. Michael.
Yeah, g'day. David, I saw one of your slides there was to do with Bidu Bush and on coastline, and you said you're using satellite imagery on a Google platform. Is it just to identify suitable habitat, or actually is it a remote sensing project to actually detect the weed itself?
Yeah, so it was the first iteration of satellite-based classification model. So it is detecting the weed itself, not suitable habitat. We're currently in a process of trying to bolster the training data set for that original model to get it a bit more accurate, because there were quite a few false positives in the original iteration. But yeah, the intention remains to use it for classifying Bitterbush itself.
What resolution was the imagery for that one? Do you know?
I believe it was 30 centimeter.
Okay. Yeah.
Yeah. So it's really in concert with drone-based classification. It's that's where it's going to be useful, because it's only going to find the big patches, of course, at that resolution. But for isolated plants, it really needs to be coupled with higher resolution imagery as well.
Yeah, we're interested in obviously going down the path of detecting individual plants, and we're going to do a couple of experiments for that in the future. And just before I stop talking, Carlos, look what I've got. Okay.
Michael, whereabouts are you? What organisation are you with, Michael?
Department of Primary Industries in Queensland.
In Queensland. Oh, great. Okay, so you're on the eradication end of bitterbush.
Yeah, so we're just examining it. We just literally have a lone camera. It's 150 megapixel drone camera. It's a large format one to have a crack and see if what resolution. I know what resolution we can get, but see if we can detect some of these smaller plants with it. Yeah.
Yeah. Oh, I can hear some future collaborations, possibly. Maybe.
Yeah,
Absolutely.
Let's get in touch, right?
Yeah, we definitely need to be getting on board with that as well, because we have a few isolated populations, and we definitely want to get on top of that. Pick up on some of the work that CSIRO and Paul Yeo from CSIRO doing that. There's probably quite a bit of data in there that needs to be picked up and taken.
Yeah, absolutely.
Yeah.
That's great.
Yeah.
Yeah, and just thinking about we've had bitterbush eradication projects in Queensland. Certainly in Queensland, but in Victoria as well, in eastern Victoria. So there are places, Western Australia, Queensland, and Victoria are places where bitterbush is not to the extent that it is in New South Wales, which is so there's a real good use for this technology in that individual plant detection, and indeed in New South Wales, north and south of our containment line. So, and then as David was showing there, within the core infestation, there's yet another use. So yeah, interesting stuff. Anybody else want to talk a little bit about what they're working on? Carlos, any new stuff happening over WA way?
Yeah. No, thanks, Hilary. And thanks for showing that camera, Michael. I've been meaning to ring you to ask how that's going. I'm really keen to see what those photos look like. We geez, in the last year, so much has happened. And so probably some of the folks in here are familiar with the skeleton weed program. We have been working with UAV surveillance for a while. And probably just to address one of the things that have been said already before I forget, just capturing false positives. I think it's just, it's unavoidable, and it definitely has to be done. Especially if you're relying on things like senescing grass in order to get in there and have a look at find your plants, it's probably never going to be too uniform everywhere to be able to target all the different places at the right time. So I think it would be important to go out there, and that's one thing that we've learned, is just go out there and start capturing as much variety in as much condition variety we can, just so that the model can learn about those false positives. It takes time and effort, but it certainly it does pay off. Because with the skeleton weed program, we have to report back to landholders fairly soon after we've detected any plants. We moved away from our main challenge, I suppose, was data transfer. So we are moving away from either posting hard drives or uploading to the clouds straight from Starlink, like the entire set of imagery. This year we tested an edge computing device that was running on the contractor's drone pilot Ute, and it was pretty much running 24/7. So it had an uninterrupted power system running in the Ute, and it was just churning the data that the pilot will copy every couple of hours. Memory card will fill up, and just swap the cards and keep on churning the data. That worked really, really, really well. And then any detections that got that met a certain criteria got straight up through Starlink to the cloud. So then we could review that in Label Studio. And then we out of all the top photos that we took, probably about 1% of the photos will be uploaded. Again, plenty of false positives. So plenty still to go to get the model to be human independent, I suppose. But that meant that we were able to get back per property to the farmer within 3 to 6 days. So that was really, really good. And we also found a bit of collaboration with the Australian Plant Phenomics Network. So those guys have got really high-end equipment. We used a phase 1 camera that's 120 megapixels in deeper. And that was really nice as well, because we could I was able to use code to process several images at a time, like in parallel, and then that meant that I could maximize the throughput and in the field. So we're capturing images at 1 frame per second, 1 image per second, and it was taking a little bit less than 2 seconds per image to process. And the processing will start just a couple of hours after we started capturing the data, because of that swapping card mechanism. All the data that was captured in the day was processed in the day in the edge computer. That was really interesting. And I've put in submitted a paper for the conference, which I think is probably going to be the next topic. Actually, I submitted a couple of papers, but unfortunately, because of WA regulation, I'm not sure if this is something that's happening anywhere else, but government officials aren't allowed in Western Australia to travel internationally unless it's unavoidable. Absolutely necessary and unavoidable. So because of all the conflict that's been happening and fuel shortage and all that. So unfortunately, I won't be able to make it to the conference. But I heard that I've heard from the committee that I can still submit the papers, and all the details are in there. If anyone wants to have to hear more details about it, or if you want to have a bit of a chat about it or anything like that, definitely feel free to contact and reach out, and we'll have a bit of a chat about it.
Yeah, and that's great, Carlos, because one of the things we can do is share the paper with this community of practice as well on our
Absolutely
testing site.
Oh, absolutely. Yeah, definitely.
We are just I know we're jumping into the next session, and we can still keep this discussion going, but Lynn's just put a question about who's going to be attending the WEEDS conference in Christchurch. One of the things that Jane and I are doing is we've put in a proposal, I guess, to do a little forum, weed remote sensing forum at the conference. So maybe we can chat with you, Carlos, because maybe there's some way we could, you could zoom you in to do the presentation.
Oh, that'd be amazing. Yeah.
Or maybe we can get someone to step up that's going to be there to do it with you and, collaboratively from afar or something.
That would be amazing. Yeah. Oh, I would love to. Yeah, I really appreciate that, because I was really looking forward to connect and so like doing all the networking, and so like there's so many opportunities that can be to like
Absolutely.
exploited. So yeah, I really appreciate that. Yeah, thanks for this. It's really great.
Before we let you go, did anybody have any questions or comments for Carlos in terms of what you were talking about there? I found that really interesting, and I actually had a question. When you're saying you're providing the data back to the landholders with the skeleton weed program, what are you giving them? What data are you giving them? Is it just about skeleton weed, or are they getting something else for it?
No. So it is just a skeleton weed. Yeah, so we usually do the search after harvest because the plant presents itself the best by then. So there's certain products that get highlighted for high risk. So it's at the moment it's surveillance flight to delineate the infestation. So if we find any detections that have been confirmed by us or by me looking at the screen and by the field officers going to the spots, then we provide the landholders with a map of like, okay, this is where it was found. Typically the program also treats that for them because it will be a first year infestation, but then from then on the landholders take over. And it goes hand in hand with another project that we worked with this year that was really interesting. And it was just getting landholders to use an open source mapping app to also go and the people that go and map their own infestations with youths driving up and down paddocks. They can use this particular app, and we provide the guidance on how to use it and all that. So yeah, and that also seemed to gain a little bit of traction. So yeah, that was really interesting. There's another paper in the conference that talks about that. Yeah.
Oh, excellent. Yeah, because I remember you talking about that before, about that you guys are doing the remote sensing work, but also collaborating with the landholders and getting them to be engaged in it. And
that's right.
That's really interesting.
Yeah.
Yeah. Excellent.
Yeah. Cheers.
I cut in and asked a question and didn't. Did anybody have any more questions for Carlos about?
Just a remark on the sort of processing in the field. I saw that we got a couple of our parks hawkweed folk on the line. I feel like that's the dream, to have processing occur in the field without having to cart around buckets full of external hard drives.
Yeah, absolutely.
Yeah, I'm just wondering with that approach. I think you said it's 1 or 2% of imagery, i.e. the positives and the false positive. That's pretty much what's getting sent, and that's all.
Right.
Using Starlink or satellite.
That's right. Yeah.
Is that coupled with, like, would people responsible for control go out at the same time? Like, is it possible to condense it that much, or do you still need to take time to review the imagery before?
Still, at this stage, it still doesn't take time to review the imagery. So we still have a bit of high false positive rate. Skeleton weed is most of the time only just stems and really thin. It gets affected by different things, so it could become quite tricky to identify. So yeah, it at this stage we still sort of like validate it on the screen remotely, and it takes about 3 to 6 days for a whole property to be reported back. From what we've done this year, but definitely we are aiming to have that happen in the field. So like we have contractors that do go and search with youths and treat anything that they find, and so that's kind of the level of performance that we want to match. And there's a paper from, pretty sure it's one of the universities. I'm pretty sure it's Charles Darwin, but yeah, they propose almost, and they do a proof of concept of having a computer out in the field that receives the map from one drone and deploys it to a spraying drone. So that type of mechanism is definitely what we want to achieve probably within the next couple of years. But it's just getting that accuracy of the model to not involve a human in the loop. That's the main challenge.
Yeah, having sufficient trust in the accuracy to
That's right.
have,
And we
have
can
no involvement whatsoever.
That's it, yeah. And we can start, I suppose, with infestations that are sort of like big tickets of skeleton with that's inequivocal for the model, and we probably would even start looking at doing looking at ensembles of models. So the device that we had out there, we were running only just a nano version of the yellow model, so it only took about, well, I say only, but it took about 16 gig of the 120 gigs of virtual RAM that this particular device has. So yeah, we can definitely we definitely have room to be processing more or running more models in parallel, or larger models, to have a little bit more confidence on the detections that we get. But yeah, it's going to be work that we're going to be developing this year. But yeah, really interesting space.
Sure.
And Carlos, could you share that paper if when you find it? The
Yeah, absolutely.
you mentioned about the automated because that's a big topic now about when can we move to that space of yes, we can find the weed and then we can spray it. That would be really fascinating, because there's a small group of people working on looking at standards for that sort of thing. Not to find the weed, spray the weed, but just at the first level, what do we have across Australia right now? What's the situation in terms of aerial spraying of weeds with drones, right? So what are the legislative policy frameworks? What are the, because that is a bit of a mishmash and it's a bit of an unknown space. But that's the sort of work we need to do at the front end to support when that technology comes online. And obviously we do have some things that are available at the moment to spray weeds from drones and so on, but we need some sort of potentially standardized approach at either national or state level. So anyway, I digress. But yeah, if you could share that paper with, even better, done. Right. Can we add it to our remote sensing COP library?
That's it. Absolutely. And yeah, I'll be really interested to hear more about what happens in that space.
Yeah. And any other comments or questions on where we're at so far? I think Sarah, was it Sarah that popped into the chat wanting to share some I missed it. I thought I saw in the chat someone was wanting to share a bit more information, but Sarah, there you are.
Yeah, I just thought earlier on when in response to David's questions about different models that we're running, and I did send a message in the background to Stephen Shelley to ask if I could throw him under the bus and put him on the spot. But yeah, I've got a couple of little things that we've been toying with that I thought I would share for people who are, because it's such a mixed bag of people at different levels. We started with some really basic tools out here. We've used 3 different models to detect one weed to see what was the best in Gary Word. So Grampians National Park, we're looking at Cello Wattle. And I just thought I'd share with you, we tried, we've used infrared just off FireWeb, which is, for a lot of people, they'll already have access to that for free. And just looking at infrared signatures was a really basic starting point. It didn't work in the Grampians because we have so many acacias with the same infrared signature, so they all came up. So then we started coding for detection instead, looking at susceptibility, and used data from R. We're happy to share that with anybody who's looking at those woody weeds. And Stephen Shelley, are you out there? Can I throw you in? Anyway, Stephen Shelley, he's doing imagery archetyping, and he was looking, particularly we use Stephen as a resource for all of our looking at the health of canopy covers. We often use him to find flora and fauna as well. And then he's moving into this weed space as well. So in terms of learnings, we're looking at flowering seasons again. That was mentioned earlier. That's definitely something that we're looking at with Kunzia in particular, or different types of wattles where we might have 6 or 7 that look very, very similar, but they might have slightly different flowering windows as well. But Stephen is a very generous and lovely resource for us. So he's our go-to for the image detecting. But anyway, Fireweb, it's free. Give it a go. Start with the most basic thing and see if the most basic thing works, and then go to the sort of more advanced levels. That's all.
We love free stuff. Thanks.
We love free stuff. Have we tried the most simple thing first? Sometimes.
Yeah, absolutely. Oh, that's great. And so that's in southwest-ish Victoria that you are, yes?
Yeah, that's right. And it's just interesting how the same species in 2 different locations can be detected with one tool in one location, and then it just totally doesn't work at all in another context. So the Otways is not that far. We're both in southwest Victoria, and in the Otways, infrared worked beautifully. That was Matthew Russell pulled that tool out and had a look because he came off fire crew, so he was used to looking at those maps anyway, looking at fire fuels and things, and he put that to the test. And it worked beautifully there, but then we tried it out here and we got so many errors of commission because there's just too many similarities in the acacias here.
Yep. Yeah. Wow. That's really interesting. And this is sort of, I guess this is really good learnings, because if we can compile all this information, as part of this community practice library, I suppose. And if you guys are more than welcome, Sarah, to provide that information, and we can add it to the site, to our community practice website, we can all continue to share that and those learnings, and hopefully we'll be able to pick up on a new tool or two, and even a free one, even better. Cool. Any questions or comments for Sarah, or what they're doing down there in Victoria? Anybody else like to share some work that you're doing or information on? I guess we've kind of gone through our first hour, which was the presentation and the Q&A, but happy to keep the conversation going if people have other things they'd like to share. I think that actually leads into our next one anyway, doesn't it, Jane, in terms of roundtable discussions?
Yeah, we're sort of going into it. Which is fine. Let's just
Yeah.
flow on of we're keen to learn what else people are actually doing, even if you don't have any results. Just people want a 2-second, doing this now, I've got a new project doing this, or and because that can often lead to people to think of things they might be doing similarly, or leading back to what Hilary and David was just talking about. So if people are currently working on projects as well. Catherine.
Hello.
Yeah.
Hey,
Hey,
Catherine.
everyone. Sorry, I was a bit late to the meeting, so apologies, David. I missed your presentation.
That's all right.
You've recorded it. You can catch up.
I know I've got his phone number, so I'll just annoy him later. But I thought, so I'm down in Victoria. I work in Agriculture Victoria, for those who haven't met me. So I was going to give Sarah and potentially Steve a heads up that I might actually send you guys an email to catch up, just to make those connections at a state level. So we've been doing a lot of work around weed detection in grasslands, and you can see I have a themed background because I've just had a master's student who's doing his presentation on Monday, and he's been looking at African boxthorn using YOLO. So so which has worked really well. I think we're finding like more and more there's like some themes like grouping underneath different architectures and those sorts of approaches. But I thought I'd give a quick update around, so we got a bit of funding last year through DAF. We'd done some previous work looking at aquatic weed detection using aerial imagery. So we've been working with, this is why I know David's phone number, because we've been working with David and Toby up at Western Sydney Weeds Authority, as well as down in Victoria, looking at how far we can push that type of algorithm, because we trained it in Melbourne for alligator weed and trying to push it out further away from Melbourne and also into New South Wales, and then also looking at alligator weed, but also Salvinia, water hyacinth, and Amazon frogbit. I'm pretty sure that's the 4 that we're looking at. So yeah, and like you'd expect, it's actually surprised me how well it worked in some areas, given like the fact that we are doing this is very basic RGB imagery. We have done no sort of corrections or anything, so it's really that sort of practitioner down and dirty. This is the stuff that we have. So it has picked up some. It hasn't picked up all of it, which you'd be surprised if it did, but it's actually working quite well for the different weights. And we've found some good sites and those sorts of things as well. So just wanted to share that we've been sort of trying to push algorithms out so that we don't have to recreate the wheel every time. We're also continuing the work in the grasslands, and I don't think they've got any calls out at the moment, but I know that there's like through the GRDCs or different RIDICs, particularly in agriculture, they're starting to actually get a bit more interested in this remote detection of weeds and using that for sort of crop estimations and or management, that type of thing. So so I think it's definitely something that people are becoming more familiar with and starting to get a bit more let's fund this sort of stuff. So
Catherine, can I ask the question with your grasslands work? So what particular grasses, any particular species you're focusing on, and obviously in grazing land, not in crops?
So this is where all the serrated tussock work that we've done previously. So that's of just keeping on going. In terms of the native stuff, we're starting to work more with like the ecologists. So at Arthur Riley Institute, they also have a group of remote sensors. So looking at like native C4 and C3 grasses as a sort of combined class, and then pushing it out a bit more to different, sort of more the ad hoc. If you've got a student who's interested in African boxthorn, I'm like, well, I know a study site with a lot of boxthorn, so here we go. That kind of work. So, but I've had, we're having some talks around looking at like willows and blackberries and those sorts of things. There's definitely lots of different people that are interested in it. So, so I think the background stuff that Hilary and Jane that you've sort of driven in terms of that reusability and that type of thing, I think is going to start really becoming more and more important. And I know we've got, so Tony Dugdale and through KISS have been having a chat around Weed Remede, which again, I'm really sorry I missed that presentation, but platforms like Weed Remede and how we sort of integrate those and make better use of those. So anyway, that's a quick update of what we're up to in AgVic.
Can I just ask one more question, Catherine? I'm big cheeky. There's when you say GRDC, there's a couple of grasses that I'm thinking of crops, also of grazing land, in terms of brome and barley grass that are expanding in cropping regions, but it's also a problem in sheep grazing regions. Do you know if that's been under the discussion at all?
So the
annual grasses.
So they're sort of, they probably wouldn't have quite as much because they're very focused on these are our crop growing regions. This is the research because it's all the farmer levies, so they've got specific questions and KPIs that they need to hit back. But working in a group like AgVic, we can then make those connections and say, hey, let's do it over here in a pasture and that kind of stuff. So that's probably more where the opportunities come from, that cropping versus, and we've done similar, like we've done previous projects where we've done a GRDC project looking at cropping areas, and now we're like, well, we've proved it over here. How about we do it do a similar thing in dairies and see if we can do that cross enterprise sort of thing. So
connect up with me if you want to look at that, because that's I'm going to Christchurch and presenting on annual grasses in sheep properties, so there might be some weed detection stuff I can do.
I'll also be in Christchurch. I'm going to present on the serrated tussock stuff, but how we've linked that back to the spatial mapping of like all the weed management activities so that we can monitor it through time, because that's sort of the next question is, well, we're doing management, we're spending X number of dollars, well, what's our actual outcome? So that's where this sort of work's headed as well. So yeah, I'll be in Christchurch too. Luckily for us, it gets classed as domestic travel and not international.
Wow, that's we had
Yeah.
to get ministerial approval, but yeah, unfortunately, it's a shame that WA can't be joining. But well, that sounds good. It sounds like there are quite a few people that are going to be there. So maybe our weed remote sensing forum will be quite good. So we might be knocking on doors of you guys that are going to be there to see if you'd like to be part of the forum, and we're hoping to bring together maybe like a panel discussion. Yeah, and whether that's something, I mean, we did try this before about sort of having a community practice meeting live at a conference. It didn't work out too well. We could try it again if people think it might be worthwhile, or we could just say live stream the forum session kind of thing, something like that. I don't know. Anyway, we'll work on that a bit, but in the meantime, yeah, thanks, Catherine. That's super cool to know all that stuff is going on. Anybody else want to jump in and tell us what's going on? I saw a few Queenslanders on the line. What's going on up in Queensland, Simon Brooks? I see you there. Was Kim on earlier? Anything exciting happening in the weed remote sensing space up in Queensland? Calling out people now. Hi, there's Kim. Hello, Simon. Putting you on the spot. Sorry.
I'm going to Christchurch as well. If we get ministerial approval to travel, we're registered. But we're mainly wearing not detection hats. We're talking about other stuff. There's 4 of us from BQ that planning to go. There's probably not a lot more going on in the detection area for tropical weeds because we're trying to source more training imagery. We've got a lot of imagery to process, but we're still trying to source enough imagery to train the model. But we do have a fair bit more internal capacity to process that now. And I think that's important because some of the previous iterations have been held externally and have become difficult to maintain or update or things like that. So. Yeah, that internal capacity is certainly working well for us at the moment.
Breaking down some barriers, maybe.
Yeah, Hillary, Bill, are you still on? And Michael and Mario? I guess I'd just like to introduce William Close to the group. So he's our, I guess, internal AI expert. So he's been doing a lot of work, I guess, with Michael and Mario, who have been leading, I guess, our BVLOS application for Cecropia in Queensland. So I guess both Michael and Mario have been at Harpass capturing for a number of years. And so we've been lucky enough to have Bill, I guess, on board for quite some time. I'll let you speak on the AI front, Bill.
Yeah, sure. Thanks very much. Thanks for the intro. And I was just sitting back and enjoying the talks, which was great. I did my PhD in machine learning and did a bit of postdoc in Germany, and then came over and worked for University of Sydney and UQ, and then transitioned across to Biosecurity Queensland. And it's just such a great opportunity to have access to so much aerial data as well, so that we can make these models. And one of our flagship projects is the detection of Cecropia peltata. And it's really nice that I had that opportunity in using our high performance computing system to make new models, testing YOLO and ResNet and other models like that. But then also to try to do this on a larger, broader scale as well. So we needed to do parallel processing. And at the moment, I'm looking at developing a platform in order to translate those results to biosecurity officers, because in the end, I end up with lots of predictions and what are those action items that then connect to it. So we've made a few presentations and happy to give that presentation next time if you would be interested. And also to just give any comment, and also great to hear what other people are doing in terms of collecting data sets and exploring other models as well. Yeah, and that's me.
Fantastic. Welcome.
Fantastic. Welcome, Clint Williams. It's great to have you in our community.
Thank you very much.
Might take you up on that as a presenter option.
Yeah, absolutely. We're always looking for, and Michael, you mentioned you might have a presentation as well. So that would be interesting too. Queensland focus would be nice. Mario, did you want to jump in and say hi?
Yep. I'm data collector, I guess. So
the important part of the process.
yeah.
To add to what Bill was saying, like we started our remote sensing. I guess we were doing remote sensing in the sense of when we were doing aerial imagery, and then we moved to using RPA to capture images, and just it started small and it grew so quick that our data management became an issue and reviewing the data became an issue. We started off obviously like most people using smaller drones and then moving to larger platforms like M300s with your 45 megapixel cameras, and now we moved on to 150 megapixel camera. So it's always going to be a point where we were collecting data faster than we could review it. We were already at that point, and having Bill come on board has offered us a solution going forward to that problem. And then on top of that, while we've been in that space, we're broadening our capability. We went from just doing standard sort of VLOS flights to more EVLOS, and now moving into the BVLOS and complex terrain. And we've just recently worked with our chief remote pilot, and we're doing over or near people to assist with a lot of the recalcitrant landholders when we're doing our surveillance as well, where we can now fly over tops of houses and people and whatnot without any issues, just because that's sometimes it can be the vast areas that use up all your time when you're surveying in remote areas, and then it can also be someone who's got a locked gate and doesn't want you to come onto the property. So we've now just about got a solution to everything.
Cool.
That's super cool.
Yeah. Do the landholders do you get any pushback from that?
We do. However, using the powers under the like we're working under the Biosecurity Act, we have a surveillance program in place that authorises what's called a aerial control measure to survey for weeds. And with that power in place, we can make entry onto the property. Well, we're not making entry; the drone's making entry on the property to undertake surveillance. We have to provide them notification in advance. However, if they refuse it, we can still go ahead with the work. Yeah.
Oh, cool.
Right.
And,
Sorry.
No, what were you going to say? Sorry.
No, I was just going to ask the team. Do you have a sort of program-based approach to this now? You've got certain weeds that are priorities that you're funneling through a sort of pipeline, or is it?
Yeah. So Bill's been with. So Bill started in a separate team, but saw obviously the opportunity to work with us. We've only been really probably 18 months working, maybe a bit longer together. I'm not even sure. Maybe it could be less. I don't know. I can't remember the exact time frames. But yeah, so we started off. Obviously, Bruce Weber got me involved with Cecropia early on. We started with Cecropia because it's an ideal candidate. We have with 4 tropical weeds, our restrained there as a training material at the moment, and we were just out, I think, a week or two ago, scaling down an embankment to try and take some photos of some closer to mature plants and in pretty hard to get to country. And the other one that we're keen to look at is Bitu Bush, obviously in Queensland. And we've been talking to Carlos and other people about what models are out there and seeing if we can adapt some of that existing stuff to assist us with Bitu into the future. But part of the reason we're doing some trials at the moment with a fairly high spec camera to again allow us to work across multiple weeds when we're doing our imagery. So rather than go out and fly multiple times at different resolutions, just do it once and then hopefully pick up on a number of different species. Yeah.
Oh, cool. Great. Well, we might be in touch, I think, in the Bitu space anyway.
Yeah.
If I can contribute a little bit, what attracted me most was that they have such a capable drone team up in northern Queensland that they collect the best data possible. And that just enables you for so many options and makes the job a lot easier, because your model is only as good as the data that you feed it, and then how you annotate it as well as all the steps that you do later on. So data augmentation, or what sort of models you choose, and all the pre-processing steps and then the post-processing steps. It all really impacts what sort of results you get out of it. And IPNA, Invasive Plants and Animals, were so well set up that it was really nice to have that opportunity to join. So they had their particular weeds that they were looking for. And what I did as an initial step was to set up a backbone of coding framework. So we tried to maximize our options by going for high resolution models, which means high accuracy. And I was a little concerned about green on green. So you're trying to detect green plants on green backgrounds in green jungles, where I was even looking over images and couldn't find the plants, even though I'm not too much of a plant person. I needed to see it for myself first. And that was the approach that we took for our framework. So now that we have the data pipeline at the maximum resolution, we can tone it back and make the entire process a lot faster. But it also makes us more compatible for our future models. So we want to detect Myconia and a number of other plants as well. And hopefully we can now just plug in and plug out our data sets and run our training models and run all of our hyperparameters in a million different ways on the HPC and see what sort of results we get back. And hopefully we can deploy them in the same way.
Amazing.
Mm.
Good to see all these structures coming into place in this space that, 10 years ago we were going, oh, can we do this? And now we're doing it. That's amazing.
Yeah,
That's great. Well, I can see some connections happening in the chat as well. So certainly some good connections between Northern New South Wales and Queensland on the video front, and particularly I think lots of other groups will be interested in the work you're doing with Cecropia and certainly the 4 tropical weeds as we go forward into the future. And great stuff. Now, Liesl, I saw you had, Lynn, I'll get to you a second. Liesl, I saw you had your hand up and you had a question in the chat. Did you want to bring that one up for?
Yeah, hi. Yeah. Thank you. So I am myself a drone pilot. I work on the hawkweed in Kosciuszko National Park, but we also work closely with our council in the private estate neighbouring. And I was just interested in the working over and near people component that you worked with CASA about. We've got a pretty good relationship, luckily, with most of our landholders in that area that we need a survey, but there are some that are just absent. They might live in Sydney and just never get comms and that type of thing. Do you have a timeline on how long that process took to work with CASA? And can you explain what that involved a bit?
Yeah, definitely. So the hardest part for that was actually trying to find a CASA-approved parachute available for sale in Australia. We end up getting, this is it here, we're going to use it next week. I don't know if you can see. No, it doesn't work. But anyway, it's called Parasero. So there's approved parachutes. So the pretty much CASA has some guidelines that says if you can reduce the impact kilojoules down to a certain threshold, if you lose control of the aircraft, you can then fly it over and above people. To do that, there's many different things. One of the things is obviously using a parachute. The requirements that we had to do were when you buy these parachutes, you have to be able to get a competency through to repack them. So obviously they have to be deployed and then repacked on a time frame to demonstrate they're still working. So that was quite we had to do some training around that and then get approval from the company we bought the parachute off. And then once we had the approval from the company that we could now repack their parachute safely, we would then had to go to CASA and we submitted this, it's called OONP, over and above or overall near people application. And we're just doing it for, a Mavic 3 because again, there's no Mavic there's no Matrice 4 parachutes available in Australia that are being approved by CASA, so we had to use a slightly older aircraft to do this. But yeah, so then we've worked through with our chief remote pilot, obviously embedded in a REOC, sent it off for approval through CASA, just got approved last week. And next week we'll be doing these first flights over and above people. Over and above people. The time frame was probably about, I'd say, close to 6 months, mainly due to the turnaround time of CASA is quite slow. Yeah.
Yes, that is accurate.
Yeah.
Oh, that's amazing. I guess a parachute wouldn't exist for a Matrice 350 then.
There are.
There are?
The problem is there are
Oh, okay.
parachutes out there that exist. The thing is they can be approved by DJI to be fitted on them and whatever set off, but it's CASA then wants you to pay for them to undertake in-house testing to demonstrate that it'll work in Australia. And if you're the first cab off the rank, it's quite expensive. But once someone's paid for that testing, then they add it to the list, and you just pay for the submission to have it added to your REOC. Yeah.
Oh, thank you so much. That's amazing.
We can talk about this a bit more. And if Bill and myself present next time, I can get our chief remote pilot to add those bits and pieces on and go into it a bit more in depth. Yeah.
That'd be fantastic. Oh, thanks.
Absolutely.
I honestly did not think the term parachute would come up in this conversation, but that's pretty cool. Lynn, did you want to jump in?
Yeah, sure. Yeah, no, I just was wanting to say thank you once again. I don't know if you can see me, but anyway, I heard a question or a problem that was stated around data management, because when you are flying, I mean, I've got clients with shoe boxes full of USBs, and they can be for, drone data, or they can be for CCTV data for stormwater and things like that. So we've been solving different problems like data management, uploading and storage and access, etc. But I was just wondering how you overcame the data management issue. I think it was Michael said that. Was it Michael?
Yes, sorry. We had the same issue. Started off with USB sticks, moved to hard drives. We've moved to a NAS drive, a RAID drive, with multiple backups. And we're currently investigating other ways to move forward. Our biggest inhibitor is not so much the storage, it's the ability to move data around quickly. Especially going forward, it's going to become more of an issue when we're collecting, we're using a 150 megapixel camera that's collecting each image is over 100 megabytes. So at the moment we're using RAIDs, but I might ask Bill to add onto it where some of the other things we're trying to investigate. But it's moving the data around to be able to be processed. It's probably our biggest bottleneck, especially working within the government department where there's a lot of security measures in place. And Bill, I'll let you pick up from there.
Yeah, sure. Yeah. I totally agree with everything you said. Bandwidth is a huge issue, especially if we wanted to process things in a pipeline where we're not waiting for batches to copy across and validate and then have checkpoints along the way, because that holds everything up. If everything could be automated and streamlined where it's processing and transferring the next file and it's there when it's up to the next one, then that would be fantastic. And we are starting to look into that approach. So this is a little bit more in cloud because data centers can provide that bandwidth. Anything that's locally hosted or a hybrid approach with cloud and on-premise data servers is tough. So there's just more hoops to jump through. But in saying that, we just recently started to write up a plan that involves the use of cloud storage. So you can have multiple levels of cloud storage to make it a bit cheaper or more expensive if you want it fast and available. And then what data should we keep and how should we keep it? And do we want geospatial mapping after the fact? So if we prove that Cicropia is not in a certain area, maybe we need proof of that. So we keep those particular maps. And maybe we need to keep them at a lower resolution or in different bit depths so we can have a repository that's all cataloged and organized. But this is a pretty big job to undertake, especially for the terabytes of data that gets collected over just a couple of days. And this is not even discussing different cameras. This is just a standardized approach with RGB or visual. If we start throwing into the mix LiDAR or multispectral or hyperspectral data, then data sets explode, storage costs go up, and things need to be manageable to a budget, I think, as well. So I think the answer is a little bit of everything. If you're not using data, cold storage, so the data needs to be rehydrated, which takes time. And then you have cool storage, so those that just aren't that important but still are accessible. And then hot storage is the things that we need accessible immediately and to everyone across the department, so we can have a faster biosecurity response. And that's my perspective on it.
Yeah, I come from the school of capture once, use many, because you can always use older data to retest your algorithm down the track. A couple of other items of news in that I've been approved to present an abstract at the AWC as well, but I might get our client to do that. What we've been working on is, because there's the satellite, the aerial, the drone capture and processing, remote sensing and identifying objects, that you then need to ground truth. And so what we've also, but a lot of stuff happens under the canopy and along roadways. And so we've been working a lot with the 4D Global Smart 360 camera, which you can just magnetically mount on a car and drive and collect panoramas in reasonably high resolution. And we've been running algorithms on that and identifying things like gazania and along the roadways, so that we can say, go forth and spray from here to here. And it's a safer way of doing that road surveillance for, say, the weeds access programs in New South Wales, etc. So I'll probably get Air Peninsula. They've got approval to fly over, and I'll get our customer there, Ben Smith, to actually present that one over at AWC in Christchurch, which will be great. So that's number one. But the other is because of the amount of intelligence that comes from this vast review, and we're collecting a lot of really important points or groups or clusters, you obviously need to ground truth. So from a rapid map perspective, and working with people, actually, like Queensland Health, I was just looking at mosquito control in the islands up north and the northern Queensland area. We've been working with them for 20 years to help with that collaborative multiple concurrent workforce. But taking those objects and then feeding them directly to our app. We've got a new app coming out called RMAP, and that's specifically to help with that remote sensing, data capture and ground truthing, but going in and actioning, because it's an N-tiered kind of model. So if you're doing RPA flights, BVLOS flights over client properties, and then you run a process and you discover what's there, then you can feed that data to a crew that's in the neighboring, in that locality, and they can go to the ground and do all the, I guess, compliance work of, going on ground and inspecting and verifying, validating, and giving you feedback almost, within the time frame that you need. The speed to get that confirmation is going to improve the algorithms every time. Yeah. So just thought I'd share that. Yeah.
That's
Right.
great.
Right, right.
Bigger and bigger
Yes,
group.
William.
Sorry, Bill. Yeah.
Yes,
No,
William.
sorry, I didn't mean to cut you off. I was just super keen in the detection of anything that's under canopies, and I think tilting cameras is fantastic, or doing a number of different data augmentations of your data sets to ensure that rich data patterns then come through, or brightness settings, camera settings, or other
Yes.
ways that we can change our model as well architecturally to make it more detectable for certain plants or certain things that are more difficult to be able to find under the canopy. And if you have any other ideas or approaches that you could share for capturing plants under canopies, I'd be super interested.
Oh, look, it's that green on green thing. And once again, I heard someone else comment earlier, it's all about seasonality. You know, you want to get the right lighting. You've got to be out there the right time of day. It's got to be the right weather conditions. You know, you've got to have the camera pointed in the right direction. 360 is a really great way of augmenting directed cameras in higher resolution, but that marriage of the data so that you can process it and then reprocess it and get as close as possible. What I was discovering yesterday with the, you know, picking up different flower heads here and here, you know, no problem. It was picking it up beautifully. And then it started identifying the bodies, you know, the shape of the plant itself and going, well, isn't this the same thing, even though the flower isn't detected? And it was really cool. Very cool.
Awesome. Thanks for sharing.
Thank you.
As always, the technology's zooming ahead. Pretty cool stuff. Anybody else want to share some information or throw out a question? Or
I was just going to ask one more of Lynn. Sorry, Lynn. You're going to put that 3D camera, 360 camera on a drone? You got it on a car at the moment. You're going to...
Well, you can put it anywhere, really. What I'll do, this particular one is really affordable, but you can rent it and things like that from 4D Global. So if you like, I can share the link on that. But look, 360 cameras come in different kind of resolutions. And I mean, you could use anything. It's just a matter of proximity and distance. We couple it often with LiDAR, but I really like also how what I'm looking for is how to incorporate some ground-based, maybe multispectral, hyperspectral cameras as well that we can put on vehicle rather than on drone. So I'm going the other way. I'm going from drone back to vehicle to get that roadway discovery. Yeah. But I'll share a link of where the smart panos really, really cool. I mean, and you can hook a LiDAR and other sensors and it's got its own GNSS and IMU. It just helps you with that interval capture, rather with drones, it's really sophisticated with respect to triggering a camera capture, whether it, and this is about capturing it at speed, at trafficable speeds. But then it feels like a video when you move through it, but then you can stop and look sideways or you can look forward. So you can get different angles and you can see it on approach, but sometimes you can't see it unless it's right beside the vehicle. And maybe it's on the left, but it could be on the right-hand side of the road, so there's lots of techniques coming up with how do we best identify that and then other weeds in that same stretch, because you drive it once and then you use it to identify others. All good?
Yeah.
But,
thank you.
I was thinking about the storage too, because we're going through the same thing at the moment, and we've built an uploader to tie objects like CCTV for drainage for a number of clients, because we go out and inspect pits and pipes and we capture a lot of data. And now, rather than them putting it in cold storage and then not knowing what's there and only getting a report to work with, we want to have it so that they can go to our map and just click on that and watch it, from a historic point of view, so they can see if there was any signs of damage before. Maybe there's a failure in 2 years after it's been, there might have been a flood and something else happened. They might want to see what it was like back when, because it's expensive to pick up.
Yeah, I was just thinking in forests, forestry and blackberry, things like that, where you can't really see underneath, how useful that might be. But anyway, we can catch up at the conference, Lynn.
Looking forward to it. Thanks.
Speaking of that, we've got a few minutes, I think, towards the end, just to talk about that. We've talked about it a little bit, but Jane, did you want to, before I say to hand over to you, Jane, to talk about that, but did anybody else want to raise any points or anything that you're doing? I did drop a proper question in the chat this time. Sorry, realized I put it in wrong last time, but one of the things, thinking about what David presented on earlier is, what types of those infrastructure information and resources would be useful for us to capture in our remote sensing library, as we call it, on our page. So I don't know if anybody has any thoughts about that. feel free to drop something in the chat. But again, that's something we'd hope this group will be able to facilitate, is all the information we're sharing here. We can either, if you have links to it or even greylit or anything that's useful for others, we can certainly add that to the library. So please do share. Jane, did you want to jump?
Yeah. So I think if no one else is wanting to share their current work, which is what we had on the agenda, I suppose we're just going to talk a bit about, well, you all know that the Australian Weeds Conference is coming up in Christchurch. As Hilary sort of mentioned, we're going to have a bit of a forum, and we're sort of not sure what that's going to look like yet. There've been a number of papers submitted as part of that, but certainly catch up with us about the conference. I'm assuming people, I'm just going to, I've got it here. Where is it? I had it up ready to share. Just in case you want that website, and I'll put it in the chat in a second, but I think everybody should have registered by now, but there's some field trip registrations, etc. open. So it would be great to be able to catch up with most of you at the conference. I'm just going to stick this in here. I don't know all of you, so that's why I'm assuming people know about it. But if you're the first time to this community of practice, this is the one we sort of all go to. If you've got any ideas or things you'd like to discuss about at that forum where we'll be face to face, please let me know. I know we have Connor here who has joined us from New Zealand. Where are you, Connor? You just reached out. Where are you? There you are. There you are, Connor. Hello. How you going?
Yeah, good. How are you guys? I just want to say thanks for the welcome, and this has been incredibly inspirational hearing all this. So I work for New Zealand Department of Conservation, and just hearing everything that you guys are working on, we're probably a good 5 years behind at minimum. All of this, we're still mostly working on manually IDing things from orthomosaic and a little bit of training of models on quite simple things like conifer species and things like that. But this has just been absolutely incredible to hear where Australia's at and where all of your agencies are at in terms of supporting the incredibly rapid development of this remote sensing work and technology.
Fantastic. Well, we hope that at the conference, Connor, there'll be connections that we can make across the ditch, as they say.
Yes.
So cross-collaboration opportunities for projects where we can, there's things that you guys can teach us, absolutely, with just the work that we've seen so far with some of your colleagues. Been fantastic work in the conifer work and the wilding pines work that some of you have been doing. So I know that during that forum, it would be good just to be able to make those connections and talk future, like where are we going? There's not been a lot of funding around specifically in this, so it's sort of finding those funding opportunities and looking for potential projects that we could, and an international focus will be really useful, because you've got a very different landscape to us, different challenges to us. So I think that we should, Hilary, we should incorporate a real good opportunity for sharing and what we're next, so that we can develop those funding collaborations. And Connor has kindly offered to help us try and facilitate across the, one of us talked about, Carlos was interested in being able to be zooming in. So Connor's kindly going to try and help us with that, Hilary. So
we'll loop you in. That's great.
That'd be good.
Yeah, definitely.
Well, maybe I wonder, I don't know if anybody has any thoughts, but I wonder, Jane, if it's worth, once we've got an abstract for the idea of what the forum would be, but maybe thinking about this approach about future and how we can better collaborate and things like that. If we kind of write up what we envision the forum to be and share it back with this COP,
indeed,
we can just share it through the COP email serving list, whatever it's called. And then if people are interested, maybe we can figure out a way to live stream that, even if it's just an hour or whatever it is that we get. We don't have a lot of time, I don't think, because it's a pretty packed agenda, but even if it's just even a 30-minute or 45-minute session that we could live stream or something, that might work really well. So anyway, yeah, we'll do that.
We'll
if
get
that-
in touch.
if that's okay. Yeah.
Connor's joined the governance team now as of today. He and I have been sharing a couple of emails. And Sandra Wotherspoon, who is your boss, Connor, or colleague?
No, she's one of my colleagues.
Colleagues, yeah. So there's a whole New Zealand team that are part of our governance group. They just haven't been able to make it due to their time difference and work. But it's just really good to have that support. I want to strengthen that ditch connection. That wasn't meant to be an attempt at a New Zealand accent. I won't even try. So that'll be great, and we'll ask you on to that. And so I'll just move on to the governance point on our agenda. We're still struggling. We've got a couple of really keen beans. We've had great help from Catherine and Lynn and Phil Price, who I don't think is here today, and obviously to help Hillary and I run this, wanting more hands. It doesn't take much to organise a COP meeting, but you know, if you're doing it regularly or more than once a year, twice a year, you know, trying to get things happening, it can be a challenge. So I'm probably going to have to step back more in the future. So yeah, I'm still obviously able to be part of this, but yeah, less leadership. So if you would like to help, would even like to lead it, it doesn't take a lot of time. It's just a thing. So if you're working in weed remote detection more so, more than what I am now, then please get in touch with me, because our governance team meets, you know, well, we've got biannual COP meetings now, but you know, we might meet at a similar regularity as well, or even 3 times a year, just to keep things moving. Where do we need to take it? And there's opportunities to grow this more. There's other community practices doing a lot more than this. It's just we're working on our capacity, Hillary and I and the rest of the team. So more hands make light work, they say. So the more the better. What else have we got on the agenda, just quickly before we finish up? Just the idea, if you've got any case studies, again, on our weed remote detection website that we host at CSU, please send them through to me. Just flick me an email and put in your details, and I can send you the little pro forma that will just get you to fill out. There's my email address in the chat. Just having that up on the website is good for people to see what's currently going, and we can change and modify things as we go. Otherwise, it remains fairly stable. We don't see where things are changing. And yeah, next meeting, I think we've actually answered that question. Oh, sorry, Lynn, you had a question? Had your hand up?
I was just thinking we're a little bit heavy on the biosecurity side. I mean, all of us were very much, you know, we're passionate about that. I was wondering if anybody's doing anything in the pasture management or soil health area, because I'd be really interested to speak with them about soil health. Yeah, Catherine. Oh, great.
Not specifically like weeds, but
no, about the actual pasture health and treatments.
Yeah. So we have so we've got an animal production research group that looks specifically at grazing, and then I'm in a crop and resource sciences group, so we do a lot of, like, I've even got a dairy soils project at the moment looking at dairy, like soils under dairies and the health.
It's about feed management in different weather conditions, but also anticipating what pasture growth you're achieving, you know, to keep the animals fed, so you could sort of like predictive feeding. And I'd love to talk to you, Catherine.
Yep, Lynn, I can reach out, but yeah.
And Lynn,
Thank you.
If you're interested, that's my background, actually, more than weed.
Right.
So if you want, if I can help as well, I'm sure Catherine's all over it from the remote detection space, far more than me. But from a livestock grazing perspective, I can help. Yeah.
Of course. Yeah, fantastic. Thank you, Jane.
We'll catch up.
And thank you, Catherine.
Christchurch.
Yes. Looking forward to it. Thank you.
Conference dinner. All right, so I think we've got some speakers for our next meeting. We had William, was it, and
Angus, are you
Michael?
Sunshine Coast, from the Sunshine Coast? Are you
still Angus?
Well, Angus, and I thought I heard a few people that were and the deeper, is it deeper? What are you guys now? Primary Industries, Queensland? What's your handle.
Department of Primary Industries. Yeah, that's right.
Okay.
Spot on.
We used to have one of those. It's now something else. Anyway, yeah, there maybe, I don't know, if we can connect with you guys and see if we could get a couple of presentations for thinking about the next COP. That would be amazing if you're keen.
Yeah, it's always good.
Excellent.
Yep, thumbs up from me too.
Right, I'm just going to make a note of that on my notes, just so that I don't forget, because it's really often we're sitting there scratching our head, going, okay, what's a good presentation that we can give, and when two people give some great discussion and yeah, just putting your names there. It's great. We'll be in touch. I'm not sure when it'll be because we've got the New Zealand conference first. It'll be probably the first COP meeting for next year, being given that we're doing two. Well, maybe we'll have another one, Hillary, this year, because everyone can't make New Zealand, and we don't want to. Yeah, I don't know.
There we go. But maybe we'll aim for something like October, November, or something like that. It's usually November-ish is pretty good.
Yeah, yeah.
Anyway, we'll call you.
Yeah.
Yeah. No, that's great. Yeah. Well, we've still got a few minutes, but if there's any other things anyone wanted to raise, or Jane, do you want to wrap us up?
Was there anything? Yeah, I was just going to say, if there's anything else you guys would like to put on the agenda for next time for discussion, just let me know if you haven't thought of anything yet, or just something you want to talk about with the group. We can put it into the agenda and even have a round table and structure that a little bit so that we've got a way for people to engage like we did today. It was really good. So yeah, let me know if there's anything you want, and we'll put it to the governance team. Whoever's running the next one, we can take that on board. It's good to have a co-design approach to this, I think, to have everyone's input. Yeah, so, but it's been a great discussion. Thank you everyone for coming. We might actually finish early. Put your hand up now if you want to have a bit of a discussion before we finish.
I'd just like to double thank David too. Oh, Carlos.
Oh, David. Yeah. Oh, sorry.
Yeah. Double thank David for a great presentation. And hi, John. I can see John there too. Carlos and John.
Yeah, no, I was just wondering on the comment that Hillary put in the chat, and also based on the presentation. I remember a few years back, you guys sent a Word document asking people which species they were working on.
Yeah.
And I think this would be a great opportunity to send another document to people just to collect what type of pipeline people are using, or what products like with Remade and all that. And for which scenarios, like we have noticed, like, because there is that issue that also Michael Graham talked about, and just the inhibition is just the data transfer. That is the case for most cases, but there's also sort of like different levels of like, okay, when do you need to have your results by? In our case, for skeleton, we need to have them pretty much within the week. But for other scenarios, it could be the case that cloud processing or things like internal high processing computer is acceptable. Like if you have a little bit more of time to get the results, a week, a month. So yeah, I think that'll be a really good way to sort of like classify those infrastructure.
Carlos, if you had ideas on, like, is that a table or something that people could, I'm going to put this over to you if you wouldn't mind, because you've got the idea.
Absolutely.
Just to send me a template or a screenshot or even a drawing of what you have in mind. I can send it out to the whole group, and those who want to send it back, or those who will have to think about a way to do that rather than my inbox filling up with 220 people.
Yeah, I was thinking maybe we
have to think
about
about
a way to make a dynamic document that people can just put in and enter in information.
Like a Google Doc or something.
Yeah.
But just an idea of what you have in mind, Carlos, and then I can send that link. We can make it up and send the link.
Yeah,
good.
Absolutely. Yeah, no, that sounds good.
Updating the list of species that people are working on. I've heard a whole bunch of new species here that I haven't heard before.
Yeah, absolutely. That's right. Absolutely, because yeah, like definitely we will be interested in joining the crew that's going to be working on B2 Bush.
Yeah.
There's definitely a lot of interest from our department in that space, and yeah, be really keen to join forces.
Very good.
Great. Awesome.
Yeah.
All right.
Thank you.
Well, thanks everyone. We might finish up there. If you have, yep, Sarah's got a message there on Bufflegrass. Cool. Keep chatting. You can keep putting stuff in the chat. I think it keeps recording in the system, so you can go in and have a look what people are putting in there. But we'll get this the copy of the link for this recording out to everybody next week sometime. Once it puts together, it'll probably be a YouTube, but like I've done before. So yeah, but thank you so much for contributing. Thank you to David. We're really great presentation, and to everyone who's discussed, and for Hilary for chairing this. It's been great, and yeah, we look forward to seeing many of you in Christchurch, online or in person, or at the next community practice meeting. But thank you so much for coming today.
Thanks, Jane. Thanks,
Yes,
everybody.
thank you.
Have a great weekend.
Thanks, everyone. You too. Bye now.
Thanks, everyone.
See ya.
Thanks, Hilary.
Thanks, Jane. That was
I'm
really
just going to turn off the recording. There we go. Stop. Okay. Here we go.
great.